When graphing radical functions, you need only know how to graph square roots and cube roots, as all even-rooted functions will look similar to a square root, and all odd-rooted functions will look similar to cube root. For this video, we're only going to be looking at square and cube root functions. When graphing them, you need to know the domain of each function. Once you know what it is, you can pick out the numbers that will give you either perfect squares or perfect cubes, depending on the function itself. So for the first one we're going to graph f of x equals square root of x minus 7. So what we need to know is what is the domain. And since we're dealing with a square root, to find the domain, we're just going to take what's underneath the root symbol and set it greater than or equal to 0. When we do that, we're going to get x is greater than 7. So we know that we have a domain that goes from 7 to infinity. So that means the first number we can even pick for this function has to be 7, because it cannot be any lower than that. So in a table of functions, or a table of values, put in 7, and if I take 7 and plug it in here, I'm going to get square root of 7 minus 7, which is going to be 0. So for my first order pair, I have 7, 0. So 7, 0. And now, because it's a square root, I'm just going to go up by 1. I'm going to go to 8. And when I do that, 8 minus 7 is going to give me square root of 1, which is just 1. So my next point is going to be 8, 1, right here. And then I need to pick something that's 4 more than 7, so I'm going to pick 11. So when I plug it in, I'm going to get 11 minus 7, which is going to be the square root of 4, which is going to give me 2. So I have 11, 2, and it's a little bit off the graph, but it's okay. We'll just say right here. We'll just imagine it's there. Now we need to know what is the basic shape of a square root graph. So square root basic graph looks like such. Starting at 0, 0, it's going to kind of go out like that. It's going to have this basic shape here. So ours is going to have the exact same basic shape, starting at 7 because of the domain, and moving off to infinity. So it's going to have this shape. So the graph of this function looks like this. So you can use decimals if you want to, like you could have got a decimal here as well, or a decimal here, but I chose nicer numbers just because I think it's easier to graph. But if you chose decimal approximations, that's also okay. Just you have to know what the basic shape of a square root graph is to be able to do this more accurately. Next we have the function f of x equaling the cube root of x plus 2. And we already know, because this is an odd function, the domain's all real numbers. So I know that the domain is going to go from negative infinity to positive infinity. So there's no need to worry about where it doesn't exist. But we need a good starting point. And if you don't know, the cube root function looks like this. It's going to have this kind of basic shape. So I need to find out kind of like where its middle point is, like right here. So to find that out, I'm going to take what's underneath the square root, or underneath the cube root, excuse me, and I'm going to set it equal to 0. And when I solve for x, I'm going to get x equals negative 2. So in my little table of values here, I'm going to have negative 2 as my first point. Because when I plug in negative 2, I'm going to get 0, as I just showed right here. So my first point is going to be negative 2, 0. So negative 2, 0. And because it's a cube root function, I'm going to go one lower than my first value and one value higher than my first value. So I'm going to have negative 3 and negative 1. And I'm going to plug them in. So cube root of negative 3 plus 2 is going to give me negative 1 and the cube root of -1 is just -1. So I have this value. And now I'm going to plug in -1, see what I get. So -1 plus 2 is going to give me +1, and the cube root of +1 is just 1. So I get this value here as well. So now I can plug in these last two order pairs, so -3, -1, and then -1, +1. So if you don't know what the basic shape is, you would think that this is just a straight line, but it's not. It has this kind of curve to it. So that means this graph is going to go like this. Now, more than likely, it's a little more accurate if you use a computer, but I have the same basic points and same basic shape, so it's more or less close enough. But in any case, you should use points that are just a little bit away from our x value here. But again, you can use approximations. If you had chosen 0, or if you chose -4, you would have got some decimal number, which will work just as fine. Just be careful to graph it as best you can. But again, just like with the previous one, you need to know the basic shape so you know what the graph looks like. Otherwise, you would think it just looks like a line.